Good evening, dear students. Am I audible? Yes. Am I audible? Yes, anyone? Yes. Am I audible?
Ma'am, yes.
Okay. Are you able to see the screen?
Yes, ma'am.
Yes. Okay. Which topic we were discussing yesterday?
Real numbers.
Real numbers. Okay. In that chapter,
In that chapter, ma'am, that proving that root 2 is irrational and all.
no. Still we have not started that part. Okay. Only we have completed HCF and finding HCF and LCM, and also we saw fundamental theorem of arithmetic. That only we discussed. We did not start, still we have not started that part. Okay. Means root 3, root 4, that today we will start.
So, ma'am,
Okay. Wait. Yes. Revisiting irrational numbers. Okay. Now tell me, what is irrational numbers? Can you give me the examples for irrational numbers? What is irrational number? A number which cannot be expressed in the form of p by q, that number we call it as a irrational numbers. Okay, means if we can express that number in the form of, then it is rational number. But if we cannot be expressed in the form of p by q, that number we call it as a irrational number. Can you give me the examples for irrational numbers? Yes. Yes, Vaishnavi. Sufyan, can you give me the examples for irrational numbers? Yes, root 2, root 3, root 5. These all are irrational numbers. Okay. Next, in this part, we are going to see one theorem, right? That theorem is very important, and based on this theorem only, we are proving next coming exercise, right? Okay. What theorem says here? Yes, anyone? What theorem says here? Let P be a prime number if P divide A square, then P divides A. See, if P divide A square, then P divides A, where A is a positive integer. Okay. Let me prove this theorem. Yes. One second. Yes, prove. Okay. How to prove this theorem? Yes, one statement is there, but we want proof, right? How to prove this theorem? Here, what they are saying, P be a prime number. Okay. P be a prime number. Let P be a prime number. Right. If P divide A square, then P divides A. How we have to remember this? If P divide A square, then P divides A. P divide A square, then obviously P divides A. Okay. Here, A is any positive integer and P be a prime number. Okay. A is any positive integer. Any positive integer. Any positive integer means it may be 1, 2, 3, 4, like this. Any positive integer. Okay. Okay. Then if A is a positive integer, then factors of A, that are P1, P2, P3 up to Pn. These all are factors of A. Okay, remember here P1, P2, P3, these all are prime numbers. Okay, P1, P2, P3, these all are prime numbers. A is any positive integer and P is prime number. Okay.
ಇದನ್ನ ಆನ್ ಮಾಡು ಕೂಸ್ಕೊಟ್ಟು ಅಂದಿಲ್ಲ.
Sorry, dear students, here network problem is there. Yes, dear students, now screen is sharing. Yes, dear students.
Yes, ma'am.
Okay. According to this theorem, squaring on both the sides, if A is any positive integers, P1, P2, P3 are prime numbers. Okay. Squaring on both sides. If we square on both sides, it will become A square. Then A square means what? A into A. Okay. Then we will write it as 2 times. P1, P2, P3 up to Pn into P1, P2, P3, Pn. That means A square is equal to P1 square, P2 square, P3 square, Pn square. What is the meaning of this statement? It is given that P divides A square. P is any prime number. Okay, let me take one example here. Okay, A is equal to 10. A is any positive integer. Okay. Tell me the value of A square. A square is equal to 10 square. That is 100. Okay. Next. Now, A is equal to 10. Tell me the factors of 10. Factors of 10. 2 into 5. Right? 2 into 5. 2 is a prime number. 5 is a prime number. Right? Now, what our theorem says? If P divide A square means P is 2, 2 divide 100. A square is 100 here, right? 2, 5s are 10, 0, it becomes 50. P divides, if P divides A square, then P divides A. P is 2, A is 10 here. 2 also divides by 10, it becomes 5. Means from this example, we can say that if P divide A square, then P divides A. Here A square is 100, P is 2, or you can take 5 also. P divide A square, then P divides A. A is 10, P divides A. Okay. Okay, by using this theorem, we will prove root 2 is a irrational number. Okay. Yes. How we are going to prove this root 2 is a irrational number? Can you tell me the steps? Already this chapter is over in your school, right? Already you did it. Tell me the steps. Root 2 is a irrational number. First step is what? Let us assume that it's contrary. Contrary means what? Root 2 is a
Rational.
no, rational. We know root 2 is a irrational number, but for proving this, we can assume that this is a
Rational.
yes, rational. We know what is rational numbers. The numbers which can be expressed in the form of P by Q, that numbers we call it as a rational number. Therefore, we are assuming here root 2 is a rational number. Root 2 is equal to P by Q. Where this condition is applies for rational numbers, PQ belongs to integers where Q is not equal to 0. If Q becomes 0, then what happens? Tell me. If Q becomes 0, then what happens? P by Q. If Q becomes 0, then P value you can take 1, Q value 0. Then tell me the answer. If any number divides with 0, then we can get not defined. This value is not defined. Therefore, the condition is Q is not equal to 0. Okay. PQ belongs to integers. Q is not equal to 0. And PQ is equal to 1. What is the meaning of this PQ is equal to 1? So there is no other common factors for P and Q other than 1. What is the meaning of this sentence? Can you tell me? There is no other common factors for P and Q other than 1. Means what? Means what? Yes, if I take P value as 2 and Q value as 3. Okay. Tell me the factors of 2. 2 into 1. Tell me the factors of 3. 3 into 1. Which one is common here? 1 is common. Means what? 1 is common for both P and Q. Okay. This is the meaning. So there is no other common factors for P and Q other than 1. Now root 2 is equal to P by Q. Implies you transfer this Q to this side, then root 2 Q is equal to P. Then squaring on both sides, what we get? Root 2 square is equal to P square. Okay, root 2 square root 2 into Q square is equal to P square. Okay, squaring on both sides. Next step, tell me. If 2 divides P square, then 2 divides P by the theorem, right? If 2 divides, squaring on means what? Root 2 into root 2. It will become 2. Okay. Therefore, 2Q square is equal to P square. 2 divide P square, then 2 divides P. Okay, by the theorem. Now we'll take P is equal to 2M. M may be any constant. Okay, P is equal to 2M. 2q square. Apply, put p value in the equation number 1. That is 2q square is equal to 2m square. Okay. Now cancel 2, q square is equal to